Welcome to our training on Zero Code Analytics. This initiative is led by AFRO's Agri-Food Working Group, the African Federation of Operations Research. The Agri-Food Working Group promotes research in agri-food supply chains in Africa for improved data-driven decision-making and enhanced food security. The goal is to support academics and professionals of logistics and supply chain fields. I am Ali, a researcher on operations research. In this session, we will cover how to predict qualitative variables using clustering. First, we will talk about the models and their parameters, then we will discuss the results. The first model we will use is hierarchical clustering. We can do hierarchical clustering without preceding the widget with a distance widget. The distance widget provides the ability to measure distances between the observations in many different distancing approaches. In this case, we use Manhattan normalized distance measurement. Second is k-mean clustering, in which we select the number of clusters. Say I want to divide my observations into 3 clusters. In this case, the observations are items bought together in a retail store. We will see how the results turn out to be in the following slides. We can let the model tell us what is the most distinguished cluster number by using the range clusters. We chose 3 clusters to select. It is up to the decision maker to select the number of clusters needed. The model here starts with a file import containing the amount bought for each type of item. Then we select the columns with the items and purchase quantities. Then we create the distance matrix and apply hierarchical clustering or apply k-means clustering right away, followed by the prediction and a projection widget. Hierarchical cluster results can be divided by a line after any dividing point to indicate where to draw the clusters. For example, if we draw a line after the first division, we will divide into 2 clusters. One with frozen, fresh, and delicatessen, and the other with detergent, papers, milk, grocery. If we draw a line after the second division, we will create 3 clusters, one with fresh, frozen, and delicatessen, and one with detergent papers only, and one with milk grocery. Notice the k-mean clustering, we end up with similar results for the 3 clusters. Many of the cluster 1 observations fall between frozen, fresh, and delicatessen. And the second cluster, grocery, milk, and detergent paper falls in the second cluster, and a few observations hovering around detergent paper alone. Those can indicate one item focused purchases. The decision maker now knows that there are a big deal of single purchases of detergent papers, so they can place it at the end of the store, for example, to create more in-store traffic. And they can separate the items purchased together, which is a common practice to let customers shop more as they go picking their target items. Thank you for choosing to learn with us. Stay tuned for more on Zero Code Supply Chain Analytics.